Hey guys, let's take a look at some separation techniques. The first one I want to think about is chromatography. Now, chromatography is a separation that we do based on solubility in water. So I have some water in a beaker here, just a little bit, we don't need a lot. And I have here a small piece of paper that we're going to use to put some materials on. So we use this a lot for inks and dyes and things like that to see if we can separate the components of those inks and dyes. So I'm going to take a blue marker and put a little dot of blue on here. I'll do a little dot of red, and I'll do a little dot of green, and we can see what components are inside these inks. So if I take this piece of paper with those dots, put it down in the water, and just let it go for a few minutes. Let me see if I can make it so it doesn't fall over. There it goes. We can start to see that these dyes in the inks are climbing up the paper as the water climbs up the paper. Let me scooch it a little closer. The different components in the dye will move different amounts up the paper depending on how similar in properties they are to water. So things that are really soluble in water, things that are hydrophilic, they like water, they're going to go up the paper farther than things that are not soluble in water or that are hydrophobic. Now you could use something other than water. You could use other liquids and see what is the solubility in a different substance, let's say like rubbing alcohol or something like that. But here we're using water. That's the most common medium for paper chromatography that we're doing here. And if we leave this a little longer, we'll start to see more separation, but let me pull it out and we'll peek. You start to see that the colors inside those inks are separating and pulling apart. Specifically that green one that was on the far right, you see those components of yellow and blue that make up the green starting to separate out. So paper chromatography we can use to separate things of differing solubilities. All right, the next separation technique I want us to take a look at is differing boiling points using a heat source or a distillation setup. So if I have some water like I have here in this beaker and I were to put some salt in it, just regular table salt, sodium chloride, into that beaker of water, and I mix that up, we have now created a solution of salt water. The water is now dissolved the salt is now dissolved in the water. So I have a solution because that salt is soluble in water. Now, if I wanted to undissolve or get the salt back out of this water, I can do that by putting it on a heat source and causing it to boil or evaporate, whatever you want to call it. We also call this a distillation setup. Now, distillation setup sometimes looks a little more complicated because they'll collect the water that is evaporating, but you don't have to. And so here I'm going to pop it on the hot plate, let it heat for a while, and we'll come back and check on it. Checking back with our salt water that is on the hot plate, we see some bubbles and some steam forming that is escaping. So our water is evaporating. We'll check back in another couple minutes and see what happens at the end. So now that we check back on our saltwater solution, if we take it off of the hot plate, we'll put it over here so it's nice and safe. We notice that all of the water has evaporated, but the salt is left behind. See those white particles of salt in there are left behind. That is because salt has a different boiling point than water. So when we heat it, the water reaches its boiling point sooner, boils or evaporates off, and leaves the salt behind, whose boiling point is much, much higher. Water's boiling point is about 100 degrees Celsius or 212 degrees Fahrenheit, whereas salt's boiling point is like 800 degrees Fahrenheit or about 1400 degrees Celsius. Some of our other techniques for separation can be pretty straightforward and we don't really need any fancy tools. For example, if we have some iron, here I have some sugar, and here I have some little plastic beads. If I were to put some of each of these materials into the same container, like this bowl here, and kind of mix it around, I've now created a mixture because I have different substances in the same container. I could easily pick out my plastic beads and put them back into their original container using something like tweezers. Or if you had a sieve, like a spaghetti colander that you use at home, a strainer when you make pasta, you could do that as well. That is separating your substance based on particle size. These are much larger. They also have a different color, but they're easy to pick out based on particle size, or they would get trapped in the sieve because they are larger, whereas these substances are smaller and could fit through the holes. When I'm left with the iron and the sugar, there's no longer a large difference in particle size, and so the tweezers are not really going to work to pick those up, and a sieve won't separate them either. So what we can use in that scenario is some of the other properties of these substances that help us to separate them. For example, iron is magnetic and sugar is not. So here I have a magnet. We always keep the magnets in a bag to make sure things don't attach directly to the magnet. It makes it hard to get them off at the end. But if I put this magnet through my mixture, the iron is all sticking to the magnet and not the sugar. So then I could get a new container here to drop my iron into, reach in the bag and pull the magnet away. There's all my iron. You always want to do this a couple of times to make sure you got everything. See, I do a second swipe and there's quite a bit more iron in that mixture. But I'm now separating based on the physical property of magnetism. Iron is magnetic, sugar is not. So we can use physical properties like magnetism or particle size and color as well. Another tool that we can use to separate mixtures is called a separatory funnel. So let me take it out so that you can see it a little bit better. A separatory funnel has kind of this bulbous shape at the top, and then it narrows down into a spout that has a valve down at the bottom called a stopcock. We can open that to allow liquids to flow out, or we can close it to make sure that the liquids stay in. So we would always use this in a ring stand situation like this with something below it to catch whatever is draining. We're going to use separatory funnels to separate liquids that are immiscible or do not mix, do not dissolve in one another. So for example, here I have some water and I have some vegetable oil. So we know water and oil don't mix. Okay, let's see. If I pour the water in to the separatory funnel and I pour some oil, some vegetable oil in, you'll notice that as it settles, we get some layers. The vegetable oil is not mixing with the water and it's creating this layer on top. So we use the separatory funnel to drain out those different layers. So our water is on the bottom, and if I open this valve, I can drain just the water out, if I can get it to open. Come on. There it goes. I can drain out just the water, and when I get that barrier close, I close it up again, and now I've trapped just the oil inside. So, separatory funnels used to separate immiscible liquids. Okay, the last setup that we're going to take a look at is filtration. So we're going to use a filtration setup, which always involves a funnel, something to catch things in, and a filter, which in this case we're just using a basic coffee filter, but there are special filter papers that you can buy depending on the porosity or the size holes that you want to use. This one, pretty standard coffee filter, and we're gonna do a mixture of water, sand, and sugar, and we're gonna see what goes through the filter and what doesn't. So I'm gonna put some sand into my water here. There's my sand in my water, and now I'm gonna add some sugar, and we're gonna stir that up. Stir that up. As we know from our life experience, sugar dissolves in water and salt does not, or excuse me, sand does not. So when I do this stirring, I'm getting all of that sugar to dissolve. The sand is not dissolving, it's staying right at the bottom. When I go to pour this through my filter, and I'm gonna get a little squirt bottle to get the rest of that sand out. When I allow that to drain through the filter, we are getting some liquid draining right down through to that catch beaker at the bottom, and we're also trapping some things in our funnel in our filter paper. So if we give it a little bit of a zhuzh, give it some breathing room, that water goes through a little faster. There we go. And let's take a look at what we've trapped. So if we take a look at this filter paper, there is all of my sand. that has not gone through with the water. The reason for that is that sand is not soluble. So anything that is not soluble gets trapped in the top. And then when we take a look at the water that has gone down to the bottom, the sugar is in here with the water. The sugar is soluble, so it dissolved in the water and went straight through the filter paper with the water. So a filtration setup is designed to separate things that are soluble from things that are not soluble.